Welcome again. Today we look at an example of electrophilic addition involving unsymmetrical alkenes. Recalling that alkenes contain at least one point of unsaturation, or one double bond between one carbon atom and another carbon atom, and that an unsymmetrical alkene contains at least one different group attached to one of these four bonds. And we will look at how these unsymmetrical alkenes react with interhalogens, like BrCl, halogens, like BrBr, and hydrogen halides, like HCl. Before considering this mechanism, let's take a look at Markovnikov's rule. The basis for the rule lies in the different stabilities of the various carbocations that can be formed, with the tertiary carbocation being the most stable owing to the inductive effect of the three alkyl groups, and the primary carbocation being the least stable, with only one alkyl group to contribute towards the inductive effect, or the pushing of electrons towards the positive center and to bring stability to the ion. Consider now an unsymmetrical alkene like 3-methyl pent 2-ene 1, 2, 3 methyl, pentene 1, 2, 3, 4, 5, pent 2-ene because the point of unsaturation is on carbon atom number 2. This is certainly an unsymmetrical alkene, as you can see. CH3, C2H5, H, and CH3. No lines of symmetry in the molecule. When a molecule like this comes into contact with a hydrogen halide like hydrogen iodide, then the electrons in the pi bond begin to influence the molecule, pushing electrons away towards the iodine, which becomes much more negatively charged as the hydrogen becomes positively charged. This hydrogen with its partial positive charge is then attracted to the negative center as it seeks out this negativity, and in so doing it is deemed to be an electrophile, and it adds across the double bond, an electrophilic addition. And in accordance with Markovnikov's rule, the hydrogen attaches to the carbon that contains more hydrogens, leaving the carbon that contains more alkyl groups to form the stable carbocation, which then becomes associated with the electron pair of this negative iodide ion, which ultimately adds on to produce this 3-iodo 3-methyl pentane. 1, 2, 3 iodo, 1, 2, 3 methyl pentane, 1, 2, 3, 4, 5. An unsymmetrical alkene associates with a hydrogen halide, the electron-rich center, polarizing the halide. As the electrons push toward the more electronegative iodide, the hydrogen becomes positively charged and becomes strongly associated with the negative center, so it behaves as an electrophile. The double bond is broken and a stable carbocation is formed. In keeping with Markovnikov's rule, the hydrogen goes to the carbon that contains more hydrogens, and the very stable carbocation, owing to these alkyl groups, is then attacked by the negatively charged iodide ion, leading to this addition reaction, an electrophilic addition. Now I would like you to draw diagrams to show the following reaction mechanisms: hydrogen bromide and 2-methyl-butene, bromine and 3-methyl pent 2-ene, and I would like you to use the IUCN rules to name the products.